Hey guys, this is video for all the people who are gone today, and there are a few of you. This is 8-1, the homework assignment that we started on Friday. You guys did the front side and you guys did the p-value method. We're starting the critical value method. Now we're going to do 7 together. You do 8 for homework, and then we're going to talk about errors down here, like things that could go wrong. So we'll do those types of things together. But for right now, we started going through 7, and then I said, oh shoot, I should be recording. So here we go. Z, they have given us the Z and they gave us negative 1.74, which means that they've already calculated this for us. They're not asking us to do that. They're just giving us one thing, negative 1.74, there it is, okay? And what we're trying to do is we're trying to compare that to having like our percentage be less than 0.27. Now, here's what you don't want to do, okay? You don't want to try to compare these two numbers, right? A Z that's negative 1.74 to a P of 0.27, because those are really far off from one another, but they're not on the same scale. Like a Z is how many standard deviations it is. Those are not the same thing. You're not comparing P to P, right? You're comparing Z, a Z score, right? So don't look at those two numbers and say, well, we're trying to compare those numbers to be the same. Those are not on the same scale, all right? So we said our null hypothesis is always equal to, we're saying equal to 0.27, and then we're claiming that P is less than 0.27. So we need to decide, is this left tail, right tail, or two tail? When we shade our bell curve. Do you remember doing this? Like left tail, right tail, two tail. Left tail because it is, I look at less than. Less than, right? If it's greater than, you shade the right side. When do you shade both of them? If it's less than equals left tail. Yeah. If it's greater than, it equals right tail. And if it's equal to and not equal to, then that is two tail. You remember that? That looks like a Z. Two tail, okay? So this one is strictly a left tail, right? And there's how that works. Okay, good? All right, critical value method. When you have one tail is kind of a little bit confusing, but I like the critical value method better. We are doing Z scores, so the Z score that lives in the middle is 0, right? And then typically, they go from like -3 to 3. I said that you could have Z's that are outside of -3 and 3 if you were dealing with really extreme values. The Z that we have is negative 1.74. That's between -3 and 3, right? So we're kind of comparing that. And we're trying to figure out where this cutoff mark is at, okay? Now here's the deal. We have a significance level of 1%. Like 0.01 is 1%, right? And if this was two-tailed, like if we had a tail over here, we would have to separate those out into two. Like 1%, there would be a 0.5% here. Don't write this down. And a 0.5% here. Does that make sense? We would have to split it in half. But we don't this time because there's only one tail. So that kind of makes it easier, right? Okay, but here's the deal. All of my 1% is going in this tail, all right? All of my 1% is going in this tail, right? And here's the thing that makes it easier for me to figure out. I want to find like the confidence level that goes from here to like the imaginary tail that's over on that side, okay? When we're doing critical value and we're doing only one tail, I kind of do like this. There's imaginary tail on that side. If there's imaginary tail on that side, there will be an imaginary 1% over there. So what confidence interval am I actually doing? You're doing 98% instead of 99%, okay? Do you see how that works? You imagine it as though it is two-tailed, and you do it as 98%, okay? So from here, I need to look up on my chart, and you're going to go to the positive side, and you're only looking at this little chart right here, okay? And we're going to 98%. So some of you guys have it. I hope everybody has it. It's written down. It should be like the last one written down. What's the Z for 98%? 2.33. Do you guys all have 2.33 written down for 98%? 2.33. It's a piece of tape. A rolled up piece of tape that I just moved. Thank you. So we have a positive 2.33 in my imaginary tail and a negative 2.33 here, right? Your confidence interval does like symmetrically on either side, so I just kind of like imagine that there's an imaginary tail over there, and that will tell me what those Z values are, okay? So using a significance level, find the critical values. Now, I said negative 2.33 and positive 2.33 were my cutoff marks. But since we're only looking at the left tail, my critical value, not S, because we don't have two critical values, we only have one, because it's only one-tailed. What's my critical value that I'm going to be comparing? Negative 2.33. I am only going to look at the left side one and not the right side one altogether. When would you look at both of them? If you had two tails, right? Okay, so we would look at both of those together. So negative 2.33 is my cutoff mark, okay? Should we reject the null hypothesis or fail to reject? We have to make that decision now. So in comparison to the 2.33, what number do I compare? The negative 1.74, right? Where does he live on this scale right here?
In the middle.
He lives over here, which means if this is my average number, and this is considered to be an extreme number, okay? Is he close enough to average to say that it's about equal to average? It's in the extreme? He's right here. The extreme value isn't anything below negative 2.33, right? So here he is, right? Negative 2.33. If it's anything lower than negative 2.33, he's considered to be like extremely lower than the average, right? Here we're saying he's not extremely lower than the average. So he is pretty close to 0.27. Like he is pretty well equal to 0.27. Does that make sense? Okay, now we never say except. We're just saying given the information I have right now, it's pretty close to 0.27, right? Like maybe in another study, we might end up rejecting, right? But in this study, we're just failing to reject the null hypothesis, which means our P is close enough to 0.27. Okay, what does that say about our claim?
It's wrong.
Claim is wrong, right? Which one did we claim?
That was going to be less than.
We claimed it was going to be less than 0.27, but we're saying with this information, we're saying it's in the safe range. It's not in an extreme value, so it's close enough to 0, which is the average, right? Close enough to a z-score of 0 to deem it like basically equal to 0.27 at this point, right? Make sense? Okay? All right, so 8, that's what you have to do. Okay, I can look at some of these z-scores, and I can tell you, look at this z-score right here, negative 3.49. Do you think that's going to be an extreme value or not an extreme value?
Nah.
Z usually goes from negative 3 to 3. So if my tails are here, right, and Z usually goes from negative 3 to 3, negative 3.4, going to be all the way in the end, right? So I'm thinking that we're going to be an extreme value, which means what? We're going to probably reject, right? Just keep that in the back of your mind. So we can go and predict some of these things. So you're probably going to be rejecting. Yeah? Okay? Do you guys want some time to do that problem? I'll give you a couple minutes and then we'll go down to errors. Should we talk about those? Okay? I'll give you a couple minutes while your brain is on that wave. If you are watching this video and want to skip ahead, just skip ahead until we start the next piece. Okay? So this is going to be a little bit longer of a video. Okay? So skip ahead to where we do errors. I'm just going to let it run. So you're claiming, okay, now here's the deal. You have P equal to 0.14. Now, first one's always equal to, and if they don't second one's gonna be not.
It's like awfully cute.
So your claim is actually going with this top one. So you're claiming that you go with the hypothesis. Yep. So in this case, you will have two tails and not a split. So 5 by 5.
Got it.
So you will still have 90% in the middle. Right? Okay. Do you know which one your claim goes with?
No.
Okay. So P equals 1/4. We always say our null hypothesis goes at the top, right? Like the equal to goes at the top. And if we're claiming that it is equal to, our claim goes with the top. That make sense? Weird stuff.
Yeah.
Yeah. So your two tails, you will have two tails. So it'll be equal to, not equal to.
So it would be plus and
Okay? Because we don't know if it's less than or greater than. So we just say equal to, not equal to. But your claim will go with the top one.
We do have it.
Yes. Yes. You will have two critical values. Okay. Confusion. Let me help with confusion.
Okay. This is.
So you have to split it.
Okay, what does that mean?
So that will help you find what percentage is in the middle here.
Well, then do I do this one or this one?
Okay, what percentage will be in the middle here? That one. So you do that one. Yes,
So our
ma'am.
claim is still wrong, right? Because it's saying that it's equal 1/4. But it equals negative 1.45 and positive.
So where is that in relationship to your 1.645?
But we're doing this one.
Yeah. So where is this live in relationship to your? So that's our, so we're rejecting this. We're saying that this is wrong, right? So our claim is still wrong. Claim is still wrong. Here we failed to reject, but we said our claim is wrong here also. So that's because our claim went with this one, right? So we failed to reject this. We're saying that this is good, which means this is bad. So because our claim was going with the bottom one here instead of the top one, our claim was still wrong no matter what, right? Because here we failed to reject, here we rejected. So we crossed them out, and it just so happens our claim ended up being wrong in both of them, even though our claim is different, right? Yeah, yeah, uh-huh. Now, we're gonna compare this.
Why shack?
Which is in, reject or abandon. Do you guys have your notes for A1?
Yeah.
Or did you guys throw them away?
No, I threw it away.
To give it a-
We were cycled.
You recycled it? Okay, then just follow along. You can just help me. All right, we're going to do an example. If you're coming back to the video here, we're going to do another example of a critical value method. And I'm going to see what we've got here. Sorry, I'm making you dizzy. Basic concepts of hypothesis testing. P-value method. Critical value method. I need an example.
What is it? What is it? It's garbage. Oh, there it is. Oh, it's considered a junior swimsuit. But anyway. This is a little bit.
54%.
But it's like soft. It's like inside of my sweatshirt is what it feels like.
Okay. I'm just going to go do example 1. How about this? Can we do this? Example 1, we'll do this one together. We don't have very much room. Sorry, you might have to go down the side a little bit. But we'll go example 1, just we get one more thing under our belt here. Okay, ready? I'm going to do my H0. I'm going to do my H1 or HA over here. And I'm going to do my bell curve right here. And we're going to do some testing things, okay? So there's my bell curvy thing. Consider the claim from the chapter problem that the majority of consumers are not comfortable with drone deliveries. Okay, majority. What does the word majority mean?
Like most.
More than 50%. So 50% is where we're going to use as our P, 0.5. Okay, so we're going to say P is 0.5. Now, I don't know if we're going to say equal to, not equal to, greater than, less than. We're going to see that here in a second, okay? Using P to denote the proportion of consumers not comfortable with drone deliveries, the majority claim is equivalent to the claim. So the claim that the proportion is greater than half. This is our claim, is that P is greater than 0.5. That's what we are claiming, okay? That's what we're claiming, all right? But for H0, we say P equals 0.5, okay? For H1, we're saying P is greater than 0.5, okay? Which one does our claim go with?
More greater than half.
The greater than, right?
Yeah.
Now, does your claim always go with the second one?
No.
No, a claim does not always go with the second one. If they would have said P equals, then we would have said our claim went up here and probably put not equal to down here, right? Okay? But since they're saying greater than, we're going to say our claim is the bottom one, right? Okay? Now, that tells me that this is how many tails? One-tailed. Which side?
So it's one-tailed. It's on
Left,
the right side.
Right side, because it's greater than. So I'm going to do right side greater than, okay? Now, do they tell me what my significance level is? Now we have to make it out, probably. What would you like to use?
99.
Let's use... Okay, hold on. Let's do this. Let's say our alpha is 10%. 0.10. Write that down. We're making that up. We're making that up because they don't give it to us because they didn't actually want us to do this test. But 0.10, okay? All right, we only have one tail, which is 10. This is 10%, right? 10%. Where does that 10% go? Do we have to split it?
Yes.
Yeah.
Do we have to split the 10%?
Yeah.
Imaginary or no?
All the 10% always goes in the shaded region. So since I have one side shaded, that 10% goes entirely in that shaded region.
When do we do the
When do
imaginary
we do
thing?
that?
That's right now. So there's 10% here, right? 10% goes in the shaded region.
So then 10%.
The percentage always goes in the shaded region. Then we make an imaginary because we have to have another side of it, right? If both of these were shaded, we would have 5% and 5%, right? But since only one of them shaded, the entire 10% goes over there. But we need an imaginary 10% over here. So what confidence interval am I looking at?
80.
80%, right? If it was split and did 5 and 5, what confidence interval would we be looking at? 90.
That's disgusting.
Confusion.
Why do they do this?
I don't know. Just to make you mad, I guess.
So
Whatever.
it's
Right?
0.28.
80%.
Did it.
So
1.28.
our number is 1.28.
Yeah.
So negative 1.28 and positive 1.28. But we don't care about the left side. We're only comparing about the 1.28. So our critical number is just positive 1.28. Yeah?
Yeah.
Okay. All right. Now, they didn't give us Z. Yikes. They didn't give us Z.
That means we have to
Shoot. That means we have to find it, right?
Okay.
Okay, this is kind of leading us into what we're doing tomorrow. We're doing the full-blown thing. P hat minus P over the square root of P, Q over N. All right, so we have to identify what P hat. We need a P, we need a Q, and we need an N. All right. We know that P is, look at your hypothesis. P is 0.5. That means Q is 0.5, right? Do you know what P hat is? What number are we comparing to? Read on. What number are we comparing to?
54%.
54%. 54%. 0.54. And what's N?
Equals 1,009.
1009. Okay. Woo!
So we plug all those in.
So we plug all those in. Z equals 0.54 minus 0.5 over the square root of 0.5 times 0.5 over N. Is this going to be a positive Z value or a negative Z value? What number are we comparing? 54% in comparison to 50%.
So positive.
He's going to be positive, right? 54% is on the right side of 50%. Okay, let's see if we can get a Z that's positive. We hope. We're almost done.
I got 2.54.
2.54.
Someone wants to
Let's see what else we got. Yeah! 2.54. We're almost done.
2.57.
Okay, let's go back to our bell curve. The cutoff mark for what's deemed to be an extreme value is 1.28. Where does 2.54 live?
Above.
Above.
So it
So
is
it's extreme.
So it's an extreme value, right? Which means that we are going to
Reject.
and we always reject the null hypothesis. I like to cross them out. So cross it out and circle this one, which means our claim is,
Right, it's right.
our claim is right.
Yeah. 'cause it's greater than 0.5.
Since our claim went with the second one, our claim is right. We claimed correctly.
Yeah.
Claim is right. Does that make sense?
Yeah.
Okay? Woo!
What did
Lots
you
of stuff.
say? It's extreme.
What?
1.54 is 2.54 is extreme.
2.54 is an extreme Z value because 1.28 is considered to be the cutoff mark.
Do you need to explain that or do you just?
No. No. So we say reject. Reject H naught. Claim is correct. Those are the two things that we really need mainly. Okay? Woo! That's like exactly what we're doing tomorrow, basically. Because tomorrow they're having you find the test statistic Z and do the hypothesis test all at one shot, which is exactly what we did today. So you're gonna be fine. Okay? Woo! All right, should we talk errors now?
I suppose.
All right, let's talk some errors here. Go to the fake 8-1 notes. Fake 8-1 notes. The fake 8-1 notes and the homework assignment. The fake 8-1 notes that looks like this. Fake 8-1 notes. The one that has the steps on the one side, all right? So we need to go down here to where it says errors. Things that could happen that are bad. We don't want to ever be wrong. But when we're hypothesis testing, there could be times where we are wrong, right? Just given on the, like we're just forming conclusions based on the data that we got, right? Well, maybe there was an outlier in our data that's causing us to get values that are not correct, right? Okay, so here's the deal. We can have 4 different things happen, right? In comparison to what is actually true. Okay, so let's say I'm gonna do innocent until proven guilty. We're gonna talk about like people who murder other people. Ready? Okay.
I'm
All
so
right.
ready.
So we're so ready. Truth about things. All right. So let's say H0 is true. Let's say our person is innocent. Okay. So I'm gonna put innocent next to here, right? So our person did not do the crime that we are accusing them for, right? And then let's say over here they are guilty, okay? So we're going to talk about both scenarios, like whether they're truly guilty or truly innocent, right? So you have an innocent person, you have a guilty person, right? Okay? All right. Good. Okay. All right. Here are some errors that could happen, all right? If H0 is innocent and HA is guilty, like we would write this out. H0 innocent and H1 or HA is guilty. All right? H0 is innocent, H1 is guilty. All right? If we reject H0, if we say that this is not true, what did we just say to them?
You're guilty.
You're guilty, right? Okay? If we reject H0, which means we cross that out, we're saying that that person is guilty. Okay? There are 2 things that could happen, right? If they truly are innocent and we just called them guilty, we have wrongly convicted somebody, right? If we just called them guilty and they are truly innocent, we have wrongly convicted them. So this is guilty when actually innocent. Okay? That's we've said that they're guilty when they're actually innocent. That is a type 1 error. Okay? Versus it could be the correct decision if they are actually guilty. If we convict them as guilty and they are actually guilty, that's what we want to have happen, right? Correct decision. Okay? Now, on the other hand, if we accept the null hypothesis, so I'm going to go back over here. I'm going to accept the null hypothesis. I'm going to circle this. I'm going to cross this one out. We are saying that they are innocent. If they truly are innocent, that's the correct decision, right? But if they are actually guilty, and we have said that they were innocent, what happens here to these people? You lucky dog. What happens to these people?
They get off easy.
They get off. We're saying that they're innocent when they're actually guilty.
Rebels.
And you guys have heard of that happening before. Like, it's just like their lawyer got them off of something, or there was something wrong and the evidence wasn't lining up, and so whatever happened, that's an error that could occur. Even though we did all of the steps completely right leading up to all the data, that is something that still happens. Like, there are still people who are wrongly convicted sitting in prison right now. Like, they're completely innocent, but they're sitting in prison. There's people out on the streets right now who are criminals who have committed murder, and somehow they were able to get off of it. It's just happened. Now, it doesn't happen very often. Most of the time we get the right people, and, you know, like, the correct people are innocent and the correct people are guilty. But sometimes that will happen. Sometimes we'll have one leak through, right? That we wrongly convict, okay? So even though we did all of the math completely right, sometimes we have errors that happen, okay? So let's go down to some examples that they have done here. Number 9, identify the type 1 error. Okay, let's talk about type 1 error. Type 1 error was rejecting the null hypothesis when it's actually true. So, rejecting H naught when actually true. Okay, that's what a type 1 error looks like. Okay, in relationship to what they have talking about here, what they're talking about here, and the type 2 error, we got to do type 2 also. Type 2 is accepting H naught when false. We're going to talk about what those are in relationship to the scenario that they have going on. All right? Are we ready? This is kind of how this sets up. The proportion of people who write with their left hand is equal to 0.29. Okay? So, H naught would say that P equals 0.29. What would H1 look like? P naught equal to 0.29. Okay? Your type 1 error and your type 2 error, we're going to write out what these look like. Type 1, type 2. Okay, type 1 error is rejecting H naught. So we're saying this is not true and this is.
Wait, can you
Unexit. Okay. I'll give you some time. Type 1 error is rejecting H naught. So this is what that looks like. This is what a type 1 error does, right? This is a type 1 error. So in a type 1 error, we would say proportion of lefties is not 0.29 when it actually is 0.29, right? We would come up with the conclusion and we would say, the proportion of left-handed people is not 29%, when it actually is 29%. All of our data led to that conclusion, but in reality, the proportion of people who are left-handed is not 29, or is 29%. Does that make sense? Okay. Let's see what the type 2 error would be. Proportion of lefties is not 0.29 when it actually is. That's what a type 1 error looks like. Okay, type 2 error is accepting the null hypothesis when it's actually not. Okay, so you tell me what this looks like. Accepting null hypothesis, which means we say that this is not true. Okay, so what would type 2 error look like?
Proportion of lefties is 0.29 when it actually is not.
Yeah. Does that make sense? All of our data led us to believe that that is happening, but that's actually an incorrect answer. Now, that doesn't happen all of the time, right? Most of the time, the people who are guilty and the people who are innocent. But every once in a while, you have one leak through and we get answers incorrectly that we should have, gotten otherwise, right? And it's not because we didn't do our calculations correctly. It's just because sometimes things happen, right? Like we have an outlier in our data that is giving us wrong conclusions, okay? All right, let's set up number 10 and let's see if you can come up with this. Identify the type 1 and type 2. Okay, so again, type 1 means rejecting. Type 2 means that correspond to the given hypothesis. The percentage of households with more than one pet is equal to 65%. P is equal to 65% or 0.65. Well, we'll go 65%. We'll write it as 65%. P is, what would our H1? Not equal to, right? If they don't tell us, we say not equal to. Okay, then we'll go type 1 and type 2. Type 1, type 2. All right. So, again in type 1, we say this and this, right? So what would that look like? Type 1, we are saying percent of households with more than one pet is what? What? Is not 65%, right? We crossed out not 65%. When,
Can you go up? I can't see.
oh, right there. There you go. Is not 65% when, what?
When it actually is.
When it actually it is. Okay, all right. All right, you figure out what the type 2 error is. I'll circle it and underline it and all that good stuff. Okay, type 2 error looks like this. We circle this one. Whoop, type 2 error. Circle this one, cross this one off. What would that look like? Okay, try and write that one out. We're circling that one and we're crossing the other one out. Okay, write in what your type 2 error would look like. There you go. Okay, good? Woo! Sorry, that was a long video, but hopefully you guys skipped through some of it. All right, goodbye people in the video.